exercise, we talk about like the key features about quadratic, okay, how to shift it, what's the movement, what dilation means. There's a smaller coefficient, the graph will get wider. If there's a negative sign in the front, the graph will be upside down, okay? So I say the positive one is with a happy face, it's like smile, and the upside down one will be a sad face, it's going that way. So negative will be sad face, and positive will be happy face. And then we talk about the translations. If move to the right, if move to the left, what's going to happen? Okay, so today we're going to sketch some parabolas. The type we sketch is with turning point form. Okay, let's have a look. So key features. Okay, key features for quadratic, which you need to label when you sketch the graph. Okay, this not only for quadratic, it's for any other graph. Okay, when you want to sketch a graph, if you have the following key features, you definitely need to label all of that. So, turning point. If on the graph there is a turning point, you must label the turning point. XY intercept, if there is XY intercept, you must label the XY intercept. So that's something you always need to label, doesn't matter what kind of graph you have. Okay, so 3 things you must label for quadratic equations. Okay, note, this is important. Any parabola is symmetric by x equals to the x value of the turning point. Okay, it's symmetric about something. So symmetric about what? Symmetric about x equals to the x value of the turning point. For example, let's have a look at this graph, this blue graph here. Okay, this blue one. The turning point is -2, 0. So this graph will be symmetric about x equals to -2. Okay, this graph will be symmetric about x equals to -2. So can you see, like, if I sketch x equals to -2, that is this line. And you can see your graph is symmetric about that line. Okay, it's symmetric about that line. So it is actually a symmetrical graph. Okay, we have this graph. Okay, both of this graph. This graph got a turning point at 0, 3. This graph got a 0, 0. So x equals to 0 will be the line of symmetry. Okay, x equals to 0 will be the line of symmetry. So you will have that vertical line. The graph is symmetrical about that. So you need to think where is the turning point. And it's symmetrical about the x equals to the x value of that turning point. Okay, so for example, this equation here. B here. So the turning point, as I said last time, the turning point is -2, 0. Okay, -2, 0. So this is actually symmetric about the line x equals to -2. Okay, symmetric about the line x equals to -2. Okay, this one got a turning point at 0, 0. So we'll have a symmetric point at about x equals to 0. There is a turning point at 0, 3. X equals to 0 will be the line of symmetry. Okay, so first you need to understand it's a symmetrical graph, but it's symmetric about the line x equals to something. Okay, the x value of the turning point. Okay, let's have a look. The turning point form of a quadratic is y equals to a bracket x minus h squared plus k. Okay, that's what we talked about last time as well. That's the turning point form. That's the turning point form. This turning point form will give you a turning point at h, k. At h, k. So this is a turning point. Okay, next what we're going to do is we can label the turning point first. If knows the turning point form, I can label my turning point. I know that is my turning point. And the next thing is make sure the shape of the graph. if it's a smile face or sad face. Okay, look at the A value. If A is positive, then it's a smile face. It's like that. If A is less than 0, then it's a sad face. Okay, it's something like that. So you can know a rough shape about the graph. Okay, a rough shape about the graph. Okay, and then we go systematically, step by step, how to sketch a quadratic by using the turning point form. So using the turning point form to label the turning point first. That's my first step. Label the turning point. Second, find out the y-intercept and label that on the graph. Okay, find out the y-intercept, which is sub x equals to 0. Okay, which is sub x equals to 0. Y-intercept. So we find the turning point by using the turning point form. I can directly read it from the graph. Second, I will use that to label the y-intercept as well. I can find where's my y-intercept. And use the value of A to decide the shape of the graph. Okay, the shape of the graph is just upside down or inverted. Inverted or upright. Okay, two ways, like smile, sad. So choose one from like those two. So then number 4 is roughly draw the shape. Okay, you can have a rough idea of what is it because you know where is the turning point. You know the shape of your graph. You can roughly sketch it. Why I say roughly sketch it or even not sketch, you just think about it. Why you need to think about it? Because you want to make sure if there's any x-intercept or not. There might not be any x-intercept. For example, I have a Cartesian plane and I have my turning point at 2, 1. So I have a turning point at 2, 1 here. And A is greater than 0. It's an upright graph. So the rough shape of my graph will be this. You can see they're not going to have any x-intercept. There's no x-intercept at all. So why are we trying to spend some time to working for x-intercept? We're not necessary to do that. So you can predict whether you will have x-intercept or not. If I'm not going to have that, you just label all the points. Y-intercept, turning point, complete the graph. Okay, complete the graph. So number 5, if you can see there's any x-intercept, then trying to figure them out or figure it out. Like you may have you may have 0 x-intercept, you may have 1 x-intercept, you may have 2 x-intercept. It depends on different graph. So the case you have no x-intercept will be that. Okay, there's absolutely no x-intercept. You can have 1 x-intercept, which is like that. Okay, both graphs will have 1 touch, just turning point, touch the x-axis. You have 1 x-intercept. Or you can just have 2 x-intercept, like that. Okay, we'll cut 2 places on the x-axis. So you can have 3 different cases. You can have 0 x-intercept, 1 x-intercept, or 2 x-intercepts. Okay, that's it. So if you can see there is any x-intercept, then you're trying to figure that out. So we make y equals to 0 in this case. Okay, we solve for x-intercept, we make y equals to 0 in this case. Okay, that's how we sketch it. Then let's have a look. Example 1. Okay, let's have a look. Example 1. 3x squared. Okay, 3x squared. It looks that is quite simple. So actually, this is the turning point form. I can make that into y equals to 3 bracket x minus 0 squared plus 0. That is still the same function. Okay, that's still the same function. But after I change that to this form, turning point will be 0, 0. Turning point will be 0, 0. Okay, I can label the turning point first. Okay, I can label the turning point first. So my turning point is 0, 0 here. I know that's the turning point. And what's my y-intercept? 0, 0 as well. You sub x equals to 0, you have 0, 0 as well. So you have this point. It's the same point. X-intercept is the same as the turning point. And y-intercept. And then I will think about a value. A is greater than 0, which a equals to 3. That is greater than 0. So I will have a shape which is this shape. Okay, which is this shape. Combine all of this information I have. I can just roughly sketch my graph in some shape like that. Roughly sketch, okay? Do not sketch on yours because I can easily take that off. This is my graph. I can see this only x-intercept is at 0, 0 there. There's no more x-intercept. So this is only one point on quadratic. It's not enough. Okay, but if it has a different y-intercept and the turning point, that's enough. It's already 2 points on the graph. But now I only have x-intercept, y-intercept, and the turning point at the same point, 0, 0, which is not enough. I better find another point on the graph to label it and see the scale. So I will say when x equals to 1, y equals to 3. 1, 3 will be another point. Okay, you can say x equals to 2. It doesn't matter. Like you can choose any point. Okay, you can choose any point. So I will count 1 and 3, which is this point here. And remember, you will have the line of symmetry, which is this one. Okay, which is this one. If you have a point 1, 3 there, you must have a symmetrical point on negative 1, 3 as well. It must be symmetrical because it's symmetrical graph about this dashed line. So you definitely will have 2 symmetric points. Well, it will be the same if you sub negative 1 into that. You sub negative 1 into that. You still have negative 1, 3. It's too narrow, it's quite hard to sketch. But remember when you sketch for it, trying to sketch a symmetrical, okay, like trying to draw a symmetrical graph. Well, mine not really looks good, but okay, something like that. Well, it's so hard to sketch on this. But you need to label 1, 3, negative 1, 3, and the 0, 0. This is a special one because x-intercept, y-intercept, and the turning point are all the same point. So that's why you need to find the extra point to finish it. Okay, find the extra point to do that. That's the first graph, which is easy. The first graph is easy. But like you need to know that is actually the turning point form. Okay, this is actually the turning point form. X minus 0 squared plus 0. That is the turning point form. So 0, 0 is the turning point. Okay, anyone can tell me what's the turning point in this case? 3, 0 turning point. Okay, 3, 0 is the turning point. Let's label the turning point 3, 0. Okay, what's the line of symmetry about this graph? X equals to 3. So it's this dashed line here. Well, you don't need to sketch this dashed line. I just sketch here for you to have a look. Okay, it's symmetric about this line. On your graph, you don't really need to label that. Okay, you don't really need to label that. So that is 3, 0. That's this point. Okay, next thing is to find y-intercept. y-intercept is when x equals to 0. Well, remember, you may or may not have any x-intercept, but I definitely will have y-intercept. Y-intercept always exists. Okay, y-intercept always exists. So you can always find y-intercept, which is 9 here. Okay, which is 9. Okay, my question is, what is another point you definitely know that will be on this graph as well? Like using the symmetry property. Like, can you find another point will definitely on this graph? Like, what's this symmetric point about this 0, 9? There will be a symmetric point about this line. 6, 9. Okay, 6, 9. So you better label a symmetrical point because you know your graph needs to look like kind of symmetric. If it's like something, I say something like that is definitely incorrect, or like something like that is incorrect, you must make it look like symmetric. So you will have this graph here. Okay, this graph here, you may have this graph here. So intersects at 0, 9, x-intercept is 3, 0 as well. You have another symmetric point at 6, 9. Okay, that's enough. That's quite enough for a graph to be labeled. Well, I don't really mean that if you have label 3 is enough. It's not really means that. Well, if I have 2 x-intercept, 1 y-intercept, and 1 turning point, they are all different points. I need to label 4 points. Okay, I need to label 4 points. So if there is x-intercept exists, y-intercept exists, I need to label all of that and turning point as well. Well, can you see there's only 1 x-intercept and it's the same as the turning point? I do have a y-intercept, so I have 2 points, and that is enough as well. On each graph, you need to label at least 2 points. Okay, on each graph, you need to label at least 2 points. So 2 points will make it like a complete graph. Like 2 is an enough number. But say if there's 2 x-intercept, 1 y-intercept, and 1 turning point, that's 4 points. You still need to label all of those 4. Because when there exists x, y-intercept, turning point, you always need to label them. Okay, you always need to label them. Okay, for C. Can you tell me what's the turning point for this graph? 0, 2. So 0, 2. So it's y equals to minus a half x minus 0 squared plus 2. So 0, 2 will be the turning point. So let's label 0, 2 here. And remember the line of symmetry will also be this. Okay, x equals to 0. Okay, y-intercept. Y-intercept is when x equals to 0, while y is still 2. So y-intercept is the same point as the turning point. Okay, y-intercept is the same point as the turning point. Okay, what shape of this graph it will be? A equals to negative half. Inverted. less than 0, so will be this shape. So I'll just roughly sketch the shape. It's like that. I can see 2x-intercept. Right? I can see 2x. There's definitely 2x-intercept exists. So I need to work for x-intercept. So I'll say x-intercept when y equals to 0. A half x squared equals to 2. Well, like is 0 equals to negative a half x squared plus 2, and a half x squared plus, equals to 2, x squared equals to 4. What x equals to? Think about this. Plus minus 2. Okay, plus minus 2. Do not answer it so quick. It must be 2 answers. Plus minus 2. You have 2x-intercept. You see that. And I must solve out 2x-intercept. That's a quadratic. I can solve out 2 possible values, right? We learned that before. Solving quadratic equations. We have learned many ways of solving it. So that's one way. We just directly solve for it. So I have plus minus 2. Well, it's symmetrical. It's symmetrical. So I'll have this shape. That point is 0, 3, 0, 2, not 0, 3. And this is 2, 0. That's negative 2, 0. Okay, next one. Y equals to minus bracket x plus 1 squared plus 4. What's the turning point in this question? Another thing? Negative 1, 4. It's minus h plus k. Okay, it's x minus h plus k. So this will be x minus negative 1 squared plus 4. Okay, it's minus h plus k. So it's minus negative. So that's a plus. So I can't have a plus sign. What's the question? I can explain. Well, that's a minus 3, so turning point is 3. It's a minus 3. I need a minus something, so it's minus negative 1 will be the equivalent to plus 1. You just think about what value can make the bracket become 0. What value can make the bracket equals to 0? Negative 1, right? Negative 1 plus 1 will be 0. So negative 1 will be the turning point. The same as this one. What value can make the bracket become 0? 3. So 3, 0 will be the turning point. So negative 1, 4 will be the turning point. So negative 1, 4 is here. I'll label this here first. Okay, y-intercept first. Y-intercept is when x equals to 0, y equals to minus 1 plus 4, which is 3. So 0, 3 will be the intercept. Okay, 0, 3 will be the intercept. This is the turning point. And what's the a value for this question? Negative 1. So it's less than 0. It's a sad phase graph like this. If it's a set phase, then something like that. I can definitely solve out 2x-intercept. There are 2x-intercept. Well, according to the shape, because it's a maximum turning point and the graph looks like that. Well, goes through this, something like that. So I'll solve for x-intercept when y equals to 0. So I will have x plus 1 squared equals to 4. What x plus 1 equals to? Plus minus 2. Okay. X plus 1 can be 2 or negative 2. So plus minus 2. Well, something square is 4. Something square is 4. What square is 4? 2 square is 4. Minus 2 square is 4 as well. So the whole thing must be plus minus 2. So it's square root both sides. Square root both sides. And you subtract 1. So x will be 1 or minus 3. Just subtract 1. Like x plus 1 can be 2. X plus 1 can be minus 2. So what x can be? X can be 1 or x can be negative 3. So 1 is here. Negative 3 is here. Yeah, that's how we solve for x-intercept. And the line of symmetry will be this vertical line here. Okay, turning point. It's the vertical line goes through turning point. So can you see I have a 0.03 here. So I will have a point here as well. Okay, it's 1 unit away from the asymptotes, and then I can go 1 unit away from the asymptotes to that side as well. Well, you don't really need to label it, but like if you label it, your graph will look more symmetrical. Okay, so you label all the symmetrical points, your graph will look better. But like it's not really necessary to label that. You must label the 4 blue points. Okay, the 4 blue points. 2 x-intercept, 1 y-intercept, 1 turning point. See, this line is x equals to minus 1. Is 1 unit away from that. You can go 1 unit away to that side as well. So this point will be negative 2, 3. Then the graph. Well, it looks like that. So I need to label 1, 0, negative 3, 0. To 3, and turning point is negative 1, 4. Well, you at least need to label all these blue points. Okay, all these blue points, you need to label all of that. 4. At least label 4 points in this question. Because you have 2 x-intercept, 1 y-intercept, and 1 turning point. They are all the key features for your graph. Anytime you draw a graph, you see all of those key features, you must label them. Label means label as coordinates. It's not enough only label the scale. Say, like for example, you label a 1 here. That's not enough. Okay, that's not enough. You must label as 1, 0. Label as coordinates. All right. Next one. Example 2. Okay, all of those 4 questions is asking you to sketch a graph. Okay, it's asking you to sketch a graph. Okay, number 2 is asking you to find the rule when a graph is sketching for you already. Okay, when the graph is sketching for you already. So the graph is like that, and you have local minimum is -1 and 2. Local minimum is just means turning point. You have turning point at -1 and 2. Okay, I want to find the equation. I want to find the equation for that. Let's just write the turning point formula again. Y equals to a x minus h squared plus k. You must write that down, okay? You must know that. That's the turning point form. They exactly looks like that, okay? It's not going to change. X minus h squared plus k. Also, there's an a coefficient in the front. Okay, there's an a coefficient in the front. So, what I'm going to do is, okay, in this question, h equals to -1 and k equals to +2. That's what the k and h value equivalent to. So I can have y equals to a x minus -1 squared plus 2. So y equals to a x plus 1 squared plus 2. Okay, you don't know the a value now. Okay, the a value is missing. Okay, the a value is missing. So what you're trying to do is using another point on this graph to substitute that in to find out the a value. So 1,4 gives you when x equals to 1, y equals to 4. Okay, this point is on this graph. You can substitute that into the equation to work out the a value. So 4 equals to a 1 plus 1 squared plus 2. So minus 2. 2 equals to 4a. A equals to half. So overall y equals to half x plus 1 squared plus 2. Overall, that equals to that. Okay, that's how we find equations by looking at the graph. Okay, if on this graph there is a turning point given, you will use the turning point formula. We'll talk about other case later when like 2x intercept is given, what we can do. So in this case, we have the turning point, so we must use the turning point formula. If you have turning point is easier way of doing this. So you use the turning point, set up the turning point formula, and then substitute another point on this graph, which is not the turning point, to solve out the a value. You don't know the dilation yet. Okay, don't know the dilation yet. You can have another, like, have a think. You can have another graph here with the same turning point, or you can have a narrow one with the same turning point. Like you can always have the same turning point, like with infinite many graphs. But you want to make sure what dilation you have to make sure the particular graph. So you will solve that by using another point on the graph. Okay, that's exercise 7B. Okay, that's exercise 7B. Wait, I'm thinking. Okay, so can you, for the rest of this lesson, so I have 30 minutes left. Can you go to page 7 and 8? Page 7 and 8. Complete square for all of those graphs. Okay, complete square. Because this is not in the turning point form. I want to see the turning point form. Okay, I want to see if I know the turning point form, I can make sure what is the turning point. And I can sketch by using the way I teach you, like in this lesson, to sketch for that. So can you just change that all into turning point form for A, B, C, and D? 4 questions. Change completing square. Okay, completing square. You have learned that in previous exercise.